Hi everyone. So in this video I am going to teach you all the basic AWS services which are required for data engineering domain. Okay. I am going to call all the services which are required for data engineering. So if you want to become an AWS data engineer, this video is for you. Okay. And after watching this video you will be ready to build AWS data engineering projects. And I'm going to use diagram based approach. Okay, so you will not get bored, I promise. We are going to use all the interactive diagrams and all so that you understand it better. Okay, and I will provide you these notes in the description. So let's begin. Okay, so our first question is S3 bucket. So as you can check the diagram, we can see a big folder. Okay, and inside that folder there are multiple files. Okay, but in AWS world these files are known as objects. Okay, so it's not rocket science. S3 bucket is nothing but a big folder which is used to store files or used to store objects. Okay, now S3 says I will let you store objects or files, but there is one limit. Okay, that limit is 5 TB. In each and every file you cannot store the data more than 5 TB. Okay, so it is very important that you should know this limit for objects. Okay, now next is AWS CLI. Okay, CLI means command line interface. And what it is, bro, it is really simple. It is just a toy. It's just a toy to play with your TV. Okay, so AWS console is the TV. Now you need remote control, right, to handle any TV. So AWS CLI is a remote control for AWS console. That's it, nothing else. Next is IAM, that is Identity and Access Management. So for example, let's say you have a company. Now Wanda is a developer, newly joined developer. For some work, she needs S3 access. Just read only access she needs. Okay, in AWS console. So as a manager, what you will do? I will just create an IAM user account. Okay, IAM user account means just username and password for her, and I will only attach S3 read only object, read only policy. Okay, I will not give control to all the services because it may end up really bad. You may have like lakhs of bill. Okay, AWS console is not a toy to play with. You may need to fire 2 lakhs. That's why. So I will only give her S3 read only access. That's it. That is IAM user. You can create accounts with the limited access. You will attach policies with limited access. Only required access you will give. Okay. IAM is nothing but a user access management. Okay. Just remember access management. Now next is S3 bucket ARN. Okay, so what exactly is ARN? So let's say we have two homes. Okay, one is Iron Man's home, another is Spider Man's home. So where does he actually live? Okay, so Iron Man lives in America. The address for Iron Man's home is America. The address for Spider Man's home is Australia. Okay, now what is the address of S3 bucket? So let's say we have another home S3 bucket. So what is the address? That address is nothing but ARN. Okay. So no matter how much S3 buckets you create, each and every bucket will have ARN. S3 bucket will have address, and that address is known as S3 bucket ARN. Okay, so remember it like this. It's nothing but a address. Now next is Lambda function. So let's say in your house, uh, actually in this diagram, your spelling is wrong. Okay, YOUR. So just ignore it. So let's say in your house, electric bulb blows. Okay, in your house, electric bulb blows. Then what will you do? You will call an electrician. He will just visit your home. He will fix the bulb and then he will leave. That's it. Okay, but before leaving, you will pay his fees for the visit. Okay, he is not saying staying 24 by 7. Just for his one time visit, he will take the fees and he will leave. Okay, so what really is Lambda function here? Electric bulb blows means event is triggered. Okay, this bulb is ruined means some event is triggering. Electrician is fixing it means Lambda running your code. You pay only for the visit means you only pay when Lambda runs. In Lambda you will create some functions, some you will write some code, and whenever you will run that code you will pay only for that. For this, electrician does not stay 24 by 7. That means server is not running all the time. Okay, whenever your Lambda code is running, only that time server will run. It is not running 24 by 7. So that is the Lambda function. Whenever any event is triggered, your Lambda function will run whatever you have written. Okay, and you will only pay for what you use. It is serverless. Server is not running 24 by 7. Okay, that is Lambda function. Now next is layers in Lambda. So check the diagram. For example, I have a restaurant where I have three chefs. Okay, these three chefs prepares the food for the restaurant. Now, first one is Chef Wanda, second one is Chef Tony, third one is Thor. Okay, so all of these three chefs required some kitchen tools to prepare the food. Okay, and they basically use kitchen racks to put all the tools required for preparing a food. Okay, so all of these three chefs have different kitchen racks for each of them. Understood? Now, the owner of this restaurant or hotel wants to do some cost cutting. Okay, he wants to do cost cutting because each of these chefs have separate kitchen racks and it is costing him a lot. Now he want to reduce some cost. Now what he will do? He will create a shared kitchen rack for all the chefs. Okay, instead of giving three different racks, he created a single shared kitchen rack which all the chefs can use. So it is costing him very less. Okay, now what was our question? Layers in Lambda, right? Now this chef means Lambda function and this kitchen rack means dependencies. Okay, so let's say we have created three Lambda functions. Now all of our three Lambda functions need to install NumPy dependency. Okay, let me zoom it. Okay, all of our three Lambda functions require NumPy dependency. So we will need to install dependency in all the Lambda functions. So instead of installing NumPy dependency in all the Lambda functions, I will just create a shared layer of NumPy. Okay, shared layer means same way, shared kitchen rack. So shared layer of NumPy dependency. Okay, now in the next Lambda function, we do not need to install the NumPy. Okay, let's say we are creating 10 Lambda functions. In 10 Lambda functions, we are not going to install the NumPy dependency. They will use shared layer of NumPy. Okay, same as shared kitchen rack. They will create shared layer of NumPy dependency. So they do not need to install it in each and every Lambda function. Okay, all the Lambda functions can use this shared kitchen rack, not kitchen rack, shared layer of NumPy or any kind of dependency. It's just an example. Let's say if you need Node.js dependency in all the Lambda functions, you can create a shared layer of Node.js. Okay, so this is, just remember, shared kitchen rack for all the chefs for this concept. Layers in Lambda. Okay, layers in Lambda. Now next is S3 storage classes. Okay, so let's take an example of storage facility where you can store your household items. Okay, so this storage facility depends on two things. Okay, there are different categories of storage classes. So where you want to store your data, because some are cheap, some are expensive, some are like frequently available. Okay, so these two questions are how often you want to access your items and how much you want to pay. Okay, these two things are very important. On the basis of these two things, your storage class will be assigned to you. Now let's take an example. Spider-Man wants to store his items in public locker. Okay, but he has different kinds of items, so he's very confused where he should store his different types of items. Okay, so he will ask storage facility in charge Wanda. Okay, so he will take help from Wanda, who is in charge of this storage facility. So she will answer his questions. So Spider-Man says, "Hey Wanda, I need frequent access of mobile. So I want to store it. So where should I store it?" So Wanda answers, use S3 standard storage class. Okay. So for frequent access, you should use this standard storage class. Now again he asks, I want automatic smart logger which can put my stuff in frequent access logger or back to cheaper lockers where if I don't use them for a long time. Okay, let's say if I want smart locker, okay, which can automatically do things for me. So let's say if I need something in urgent, it will be automatically stored in frequent access logger. Or let's say I don't need it much now, my work is done, so this smart logger should automatically put it in long term cheaper loggers. That is, then Wanda answers S3 intelligent tiering storage class. Okay, if you want that smart logger, then you should use this S3 intelligent tiering. Got it? Now Spider-Man needs cheap locker. For the items he does not use much, like winter jackets. He only uses it once a year, right? Then Wanda answers use S3 standard IA. IA means infrequent access. Okay. So if you don't need items frequently, you should use this S3 standard IA, which is cheap as well. Now again three more questions he asks. Spider-Man says, I have old furniture, I want to store it, but I don't care if it is destroyed. That means it's not much important. Okay, it is just optional. So in this case, Wanda answers use S3 one zone IA. Okay, whenever there is IA, IA means infrequent access. Got it? Now Spider-Man says, I want warehouse in another city for storing farm materials. Okay, then Wanda answers use S3 Glacier. It is cheap, but you must request it in advance. Okay, because this warehouse is out of the city and it is cheap as well, so it is kind of an infrequent access. So we should use S3 Glacier, but we must request in advance if you need it. Now, lastly, he asks, I need cheapest underground storage for storing old newspaper. Okay. Now, Spider-Man needs very like most cheapest storage class for storing newspaper, because we know newspapers aren't that much important. Okay. So if you need cheapest one, you should use S3 Glacier Deep Archive. Okay. It is very cheaper, but it takes some most time to transfer the data. So we should use it for data which is not that important, like newspaper. Okay. So these are the types of storage classes, and as per our need and as per our budget and how frequently we need to access them, these are the different types of storage classes which are available in S3. So you can remember this example of Spider-Man and Wanda. Now next is what is encryption in S3. So let's say someone steals your data, still they cannot see what's inside. So let's take an example of iPhone. Okay, even if your iPhone is stolen, still they cannot unlock it. So still your data is safe. So same way, if someone steals your data, they still cannot see what's inside because they don't have a key. This process is called encryption, means safety. For let's say example, I want to keep my gold in the bank. Okay, so there are three types of encryption. So first, you are just putting your gold in the locker, but still there is no lock. Let's say if someone opens this locker, they will get access to the gold. There is no lock inside. Okay, so this one is called no encryption. Now, second one is server side encryption with S3 managed keys. So you have put your gold in locker, but inside that locker, that gold is stored in box where lock is provided by the bank. Okay, so inside locker there will be one box and that box is locked. Inside that gold is present. So in this case that lock is provided by bank. So same way key is provided by AWS, so we can keep our data safe this way. This is server side encryption with S3 managed keys. And third one is KMS, key management service. So same situation as above, but this time the lock is not provided by the bank. we have bought new lock for ourselves, so we are managing the lock for the gold. Okay, so that is the difference between key management service and S3 managed service. So in S3 managed keys, key is provided by AWS. In key management service, key is provided by yourself. Okay, you manage the keys, not the AWS. Okay, these are the three types: no encryption, server side encryption with S3 managed keys, and AWS KMS, key management service. These are the three types. Now next one is CloudWatch. Okay, it is very easy. It is nothing but a monitoring service. Okay, so let's check the diagram. We will take one example. Tony Stark has constructed one mall. Okay, one big mall he has constructed. Now he wants to maintain this mall. Okay, so maintaining a big mall is not easy, we all know that. So he will use different kind of services. Let's check which services he needs. So Tony Stark needs CCTV camera for his mall. Okay, so they record what's happening in each shop. This is same as CloudWatch logs. Okay, CloudWatch will keep logs for your AWS service. Now second service is thermometer and smoke detectors. Okay, so these machines constantly measure the environment conditions. Okay, so same way CloudWatch will monitor your metrics. Okay, so it will keep the data for your services. Understood? CloudWatch will store metrics. Now third one is mall alerts. Okay, so let's say in that mall if something unusual happens, or let's say fire is there because of some accident, then there should be some fire alarm. Okay, so same way we can put alarms in CloudWatch. Okay, so condition we can decide, like for example, let's say whenever my bill goes above $100, I need one alarm, so I can get that alarm on email. Okay, so this is CloudWatch alarm. It is third feature. Now fourth is, in that mall there will be control room dashboard where all the information will be available for CCTV camera, for smoke detectors, for mall alerts. Every information will be available on that in that control room dashboard. So same way in CloudWatch all the information will come together and you can see everything at one place. So that is CloudWatch dashboard. Okay, so first is CloudWatch logs, you can store logs. Second one is CloudWatch metrics, we can store the metrics. Third one is CloudWatch alarm, so we can put different types of alarms, for example email. And fourth one is CloudWatch dashboard, where you will see all the information at one place. Okay, next one is producer. So what really is producer? So for example, let's say Hela is the robot and she says, I uploaded one file in my system, now I have created an event, so I am the producer. So producer means basically whatever that generates an event. Okay, for example, you upload any image file on S3 bucket, so S3 will become producer. Okay, an event will be generated, then that event will be sent to some service which will route to appropriate consumer, like event bridge. Okay, so this event bridge acts like post office, which will just route this event from one service to another. So we will see it later. Now next is event bridge. So event bridge any AWS service. So okay, so first let's take an example of Loki. Loki is just like a postman, receives an event and send it to Thor. Okay, so same way, event bridge is an AWS service that receives a event from producers and send it to the consumer, right consumer, appropriate consumer. Okay, understood? It will just receive an event from producers and route it to appropriate consumers. So just remember postman. Event bridge is nothing but a postman. Now third one is subscriber. So let's take an example of Thor. Thor has subscribed for such events. So he will receive notification whenever that event occurs. Which event? Just now we have seen. Let's say someone has uploaded image file on S3 bucket. So that will become event. And subscribe this Thor has subscribed for that event. So he will receive notification. That's it. That is the subscribers. You will receive notifications for the event you have registered or you have subscribed for. Now fourth one is consumer. Example, Odin has received an event. Now he will take some action on it. Okay. So that is the consumer. Consumer is a service that takes some action after receiving event or message. Okay. I will repeat what is consumer. Consumer is a service that will take some action once it receives an event. For example, a Lambda function that processes the file after S3 uploads it. So S3 uploads the file, that is event, and once Lambda receives that event, he will take some action on it. That could be anything, like let's say there is a Lambda function to reduce the file size. Okay, so Lambda will become consumer because he is taking action on it. Now next one is SNS. This is simple notification service. So it is basically used to send the message to many people or many system at once. So we will understand this with one example. Let's check the diagram. Okay, let me zoom. Okay, it's enough. So let's say there is one WhatsApp group. Okay, there is one WhatsApp group. So whoever joins the group, they will become subscriber. Whoever sends message in this group, they will become publisher. And all the group members will receive the message. Okay, so they will become subscribers. And this WhatsApp group is a topic. Okay, so WhatsApp group is topic. Members join the group are subscribers. All the group members will receive the message, they are also subscribers. And whoever sends the message, he is publisher. So but in SNS, unlike WhatsApp, we will also receive SMS and email. Okay, in WhatsApp we just receive SMS WhatsApp message, but in SNS we can receive email as well. Now let's check what are the key concepts in SNS. So we will take one more example of notice board. Okay, so there is one notice board in housing society. So different types of notifications will be written on this board. Okay, so that board is the board will become topic. Okay, and the society manager who is posting a notice, he will become publisher, and the residents who want updates, who will read those updates, they are subscribers. Okay, so notice board is topic, society manager writing the notice is publisher, residents who wants to read it and they will receive updates are subscribers. So these are the key concepts in SNS: publisher, topic, and subscriber. So you should remember this. Now next one is SQS, that is simple queue service. So simple queue service means send the message from one system to another, but without both system needs to be active at the same time. Means it's okay that both the systems are not online, that is completely fine. It is not compulsory for both the systems to stay active. Okay, so let's understand this with clear example. So let's say whenever customer is hungry and he wants to order some food, so he will use food delivery app like Zomato, and that request should go to kitchen. Okay, now let's check these two scenarios. Without SQS, customer will make direct call to kitchen, and let's say kitchen is busy on the call with some other order, then that customer is lost. Okay, but let's say in second scenario we use SQS, so mobile application will drop the order in mailbox. If the kitchen is busy, kitchen will finish its previous order and then it will take this pending order from mailbox. Okay, if the kitchen is busy, order will wait in the mailbox in the line. Okay, so it will wait in queue, and if the kitchen is closed, it will wait until the kitchen reopens. Means customer is not getting lost here, customer order will wait in the queue. Okay, so that is the advantage of SQS. So in this example, customer app is the producer, kitchen is the consumer, and mailbox means queue. Okay, so I hope you understood this. SQS, both the system does not need to be active at the same time. Okay, kitchen is not, in the second case kitchen is not active, customer is active. Okay, so next one is event bridge. Okay, so we all know what the producer is. Any service which produces the event is producer, right? And any service that take actions on that event is consumer. But what really is event bridge? Okay, so he is nothing but a middle person. Okay, he is a middle person which routes the event from producer to consumer. Okay, he will just transfer the event from producer to consumer. Okay, so remember it, it's like a postman, it's like a middle person. Okay, so event bridge is very easy. Now what is event bridge pipe? It is actually very similar as event bridge. So event bridge pipe says I will move the event from source to destination. Okay, same as event bridge, it will move the event from source to destination. It's just that along the way it will do some transformations. Okay, so as you can check the diagram, that event is transformed event. Earlier it is I'm just taking it as an example. So earlier it is rectangle, now it is star. So it is transformed event. Okay, these diagrams and all is just for your understanding, so just try to remember it. It will transform the event from source to destination, that is event breach pipe. Now next is Kinesis data streams and Kinesis Firehose. So as you can check the diagram, producer is producing the event. In this case, producer could be like any mobile application or IoT device which is generating a real-time data. So Kinesis data streams is just an AWS service which process real-time data. Okay, it will process real-time data. Now, what is Kinesis Firehose? The Kinesis Firehose, these are the pipes which will collect the real-time data, transform it, and transfer it to the data lake, which could be S3 or Redshift. Okay, so we can just simply say it will transform the data from source to destination. Okay, these are Kinesis Firehose pipes. This will transform the real-time data from source to destination. Now, date later queue. What really is date later queue? Okay, we have one more character SQS. Okay, so SQS brother is a good boy, but he does not like to work again and again. Okay, he just likes to try once, otherwise he will just dump the message in another box called date later queue. Okay, so let's see what SQS says. So SQS says generally the message will be processed here in queue. Okay, that is the primary job of SQS. It will process the message from the queue one by one. But let's say any message is corrupted or the data is wrong, then it will not retry again and again. Okay, it will just store it in special mailbox called date later queue, and then AWS will later investigate it. Okay, but SQS will not waste time on it. He will just try once, otherwise he will store in date later queue, that is different mailbox. Okay, this is date later queue. Now what is EC2 instance? Okay, in AWS, so it is just like you will rent the physical computers on the cloud. Okay, instead of buying physical computers by yourself, you will just rent it on the cloud. Okay, so EC2 instance means rent the servers or computers. Now what is meant by SSH in EC2 instance? So let's say this EC2 server is your TV. Now you need remote to access or control this TV, right? So you need remote, so that remote will be terminal. But in this case, EC2 server is locked, your TV is locked. So you will use terminal, we will use key value pair to unlock your TV, and then you will access it. Okay, so SSH in EC2 instance means using remote to control your TV. Okay, SSH means using terminal to access the rented server like AWS. Now what is AWS Athena? Okay, let's say your data is stored in database like MySQL. Then we all know that we will just use SQL to query this data or to access that data, right? But let's say if what if your data is stored in S3 bucket in different formats, not in table format, in different formats like CSV, Parquet, JSON. Okay, then how will you query that data in S3? Simple, answer is simple. You just use AWS Athena. AWS Athena will let you query this data in S3. using SQL. Simple SQL you will use, right? So AWS Athena lets you query data in S3. Now let's say some interviewer asks you this question: what is difference between Spark and Athena? Then what will you answer? Answer is simple, bro. Athena is just used for querying the data in S3. Okay? And Apache Spark is used to transform and process the large amount of data like big data. Okay? So there is huge difference between both of them. Athena is for querying and Spark is for transform and process. Okay? So query and transform, these are two different things. And Spark is generally used in big data. Okay? So Athena is used for querying data in S3. Spark is used to transform and process large amount of data. What is AWS Glue? Okay, so it's a service from AWS which will first collect the raw data from sources like S3 or RTS. Then second step it will do is clean and transform the data. Okay, third step is finally it will send data to destination, which could be like data warehouse or data lake. Okay, so what is AWS Glue? It will collect the data, clean the data, and send it to data warehouse. Okay, it's an AWS service. Now what is ETL jobs? ETL stands for extract, transform, and load. Okay, so this, as you can check the diagram, this raw data is converted into transform data using Python scripts. Okay, so in the green boxes you can check these are Python scripts. This Python script is nothing but ETL job. So we will write ETL jobs to transform the raw data into the desired data which we want. Okay, so ETL job is nothing but Python scripts. Now what is glue crawlers and glue catalog? So we all know that raw data will be converted to transform data using AWS Glue service. But do you really know what happens behind the scenes? Not exactly, right? So we will check that. First, these are the glue crawlers, like you can check spider like diagram. These are the automatic robots which will crawl the raw data and collect the information about its format. Okay, it will collect the information about the raw data like column name, data type, etc. Understood? So these glue crawlers will collect the information about raw data. Then it will create glue catalog. Okay, so whenever you visit any restaurant you will check menu catalog, right, which contains the information about the food. So this glue catalog which is created by glue crawlers will contain the information about your data like column names, data types, etc. Okay, so first step is crawlers will crawl the data, raw data, and collect the information. Then it will create glue catalog, that is second, which will contain the information about raw data. Third will be Python scripts. We have already seen that ETL jobs, right? These are Python scripts which will use glue catalog. Okay, these Python scripts will use glue catalog. Finally, data will get transformed. Okay, I will repeat one more time. We have raw data like, so AWS will use glue crawlers to collect the information about raw data. Then it will create glue catalog which will contain the information about your raw data like column name, data type. Third will be Python scripts. Finally, data will be transformed. One more important information I want to share regarding AWS Glue is it is serverless. Okay, you do not need to set up servers. AWS will take care of the resources to run your ETL job. Okay, so it is not at all your headache. AWS will take care of it. You just have to write the ETL job. That's it. Okay, so AWS will take care about servers and all. It is serverless service, so that you can focus on Python script ETL jobs. Now next is Glue Studio versus Glue Visual ETL. Okay, so Glue Studio is a service actually, and Glue Visual ETL is it's just a feature inside Glue Studio. Okay, so Glue Studio is a service. Glue Visual ETL is a it's just a feature. Okay, so what is the use of Glue Studio service? So it's a complete service where we can create, run and monitor jobs. Okay, we can do everything because it's a complete service, and Glue Visual ETL means it's just a feature. It's just a drag and drop feature for creating PySpark jobs. Okay, we can create Glue jobs using drag and drop like option. This is Glue Visual ETL, and Glue Studio is a service name. What is partitioning and bucketing in Athena? Okay, so inside Athena, we can actually partition our database. We can partition with any metric, like we can partition with date, we can partition with regions, or with year. Okay, now bucketing means we can further again we divide that partition. Okay, let's say we have partition data with date. Now again we can partition that data like box 1, box 2, box 3. Okay, so we can take the example like this. Let's say partitioning means your cupboard for separate things. Okay, you have separate cupboard for shoes and you have separate cupboard for your clothes. Okay, now inside again that separate cupboard you will have boxes. Okay, you will have boxes inside each cupboard, like box 1, box 2, box 3. Okay, that is bucketing. So remember it like this. Partitioning means separate cupboard for separate things. Now bucketing means inside each cupboard will have boxes for putting data. Okay, but why are we doing this? What is the real use for doing all of this in Athena? So these are the couple of advantages, like data searching will be faster, right? Because whenever you will query data, it will look in that particular section, in that particular box. Okay, rather than searching in the whole cupboard, it will just particularly search in that box. Okay, that is why data searching will be faster. It will reduce the cost of AWS Athena. Okay, that is the second advantage. And third is data will be organized. Okay, so that's why it's not compulsory actually, but it's a great practice to perform partition and bucketing in AWS Athena. Now next one is lake formation and its features. So what is lake formation? It's like a manager for data lake. It will do everything related to data lake. Okay, all the features at one place. So let's check what are the features of lake formation. So first is central security, means on single dashboard you can set permissions and rules to all the relevant services. Now you do not need to visit each and every service and then set permissions from there. Okay, you can do everything at one place. You can set the rule for all the services at one place. Okay, so that is central security. In centrally you can set all the permissions. Okay, that is the most important feature of lake formation. Second one is data catalog. Okay, so let's say lake formation is saying I will give you all the information regarding your data. Okay, I will act as a data catalog. So I will give you information related to what tables you have, what columns are inside, and what is the address of data in S3. Okay, where your data lives in S3. That means lake formation is acting as a data catalog. Now third feature is data ingestion. So lake formation is saying I will help you bring the data from different sources to your data lake, means S3, right? I will help you bring data from different sources. Fourth one is data transformation. I will help you clean and transform the data using AWS Glue. Okay, so it's like a manager for data lake. You can do all the things related to data lake at one place, be it transformation or ingestion or like security and permissions, your data catalog, everything will be present in lake formation. Now next module we are starting. Okay, so what is AWS Redshift? AWS Redshift is a data warehouse provided by AWS. Okay, we all know that what is the difference between data warehouse and data mart. Okay, sorry, data lake. Okay, so data lake is S3 and data warehouse is AWS Redshift. Okay, so data warehouse is a place where we can store and analyze large amount of structured data. Okay, next, what are the features of AWS Redshift? So first feature is we use columnar storage. So check the diagram. In traditional database, we generally use row storage. Okay, we read the data row by row horizontally. So if from this first table I have to find marks, okay, but I am reading row by row, so I will have to check name, then age, then class, and then marks. Okay, so for each and every ID, I will have to read all the columns like name, age, class, and then I will get marks. So that is very slower. But in case of AWS Redshift, we use columnar storage. Okay, so for each and every column, we have separate page. Okay, for each and every column, we have separate page. So if from the same table, I have to find marks. Okay, let's say suppose this table is stored in Redshift, and if I have to find the marks, then I will directly go to the marks column page. I don't have to read name, age, class, etc. Because we are not reading data horizontally, we are reading by columns. For each column we have separate page. So I will directly read marks. Okay. So in this case, the query is getting processed much faster. Okay. No, because we are not doing any extra reading. That is why it is faster. So this is our first feature. AWS Redshift uses columnar storage. So second feature is parallel processing. So let's understand the diagram. So let's say you want to perform some large query on big data. Okay, so you want to perform some query on large amount of data, large data set. Then next step will be this query will be converted and divided into smaller tasks. Okay, this query, large query, will be divided in tasks. Then what is the third step? We have AWS Redshift cluster, right? So these tasks will be assigned to separate nodes. These nodes are not dependent on each other, right? We all know that they work parallelly. They are not dependent on each other. So these tasks will be assigned to separate nodes. They will perform this task parallelly. Okay. Then fourth step will be finally result will be combined and we'll get answer. That's why we get faster results in parallel processing, because large query is divided into smaller tasks. Smaller tasks are assigned to separate nodes and these nodes works parallelly and the result will be combined. So second feature is parallel processing. Now third feature is scalability. So for the first time, whenever you will set up a Redshift cluster, the cluster will be small. Okay, because your business is also small, right? Initially it will be small, then gradually it will increase, right? So AWS Redshift is scalable. As your business grows, you can also add more nodes whenever you want. Okay, because cost will also increase, right? So it's like pay as you go. As your business is growing, you can add more nodes, you can increase the cluster. Okay, but initially it will be a small setup because cost is very related with the cluster. That's why. So third feature is scalability. So fourth will be integration. We all know that AWS Redshift integrates well with other related AWS services. Okay, so Redshift can integrate with S3. We all know that use of S3, we can store the raw data in S3, right? It Redshift can integrate with Glue, which is useful for transforming and cleaning the raw data. Redshift can integrate with Athena. Athena is used for querying the data directly from S3 buckets. Redshift can also integrate with QuickSight, okay, which is useful for creating dashboards and reports, basically creating visualizations. Okay, so Redshift can integrate well with all these services. So that is the fourth feature, integration. What is the architecture of AWS Redshift? So the parent node says, bro, I am the boss and these child nodes are all my workers. Okay, I am the boss, these are all workers. So main important things are done by parent node. Let's see. So first, whenever we want to query something, okay, that query goes to parent node. Okay, parent node receives the query form from user. Okay, then parent node will convert that query into smaller tasks. Okay, after that he will send that small tasks to child nodes. Child nodes will execute those tasks and send the result to parent node, and parent node will collect the result and give us the result. And this is architectures. Let me repeat one more time. Parent node is the boss, child nodes are the workers. So whenever we send query goes to parent node. Parent node will divide the query to smaller tasks and assign to worker nodes. Worker nodes will perform the tasks and send the result to parent node. Finally, parent node will collect the result and return to user. Okay. So this is the AWS Redshift cluster, and this is the architecture. What is materialized views in Redshift? Okay. So this is nothing but saved query results for faster output. Okay. Whatever we query, results will be saved so that we get faster output. Same as caching. So I will give you example of Facebook. Okay. So whenever for the first time when you visit Facebook, it will take some time. After that, it will store your data in the cache. And if you have observed, next time if whenever you will visit, the loading speed will be faster. Okay, because data is already saved in the cache, so that you get the output fast. So same process is followed here. Let's say user wants to query something. Okay, then the output will be saved in table like structure. Okay, inside Redshift internally there will be one table and output will be saved in the table like structure. And next time whenever you ask him the same query, you will get the faster results. Okay, because it is materialized view, query is already saved in the background. Okay, these are the main advantage of materialized view. Now why we use materialized views? Let me scroll down. As we all know, it will speed up the query on larger data set. It will reduce the cost. Okay, because we are not recomputing the same joins and filters. Third, it will be good for dashboards and reports, because in dashboard we need to refresh the data daily, right? We need updated data. So queries will be saved in the background in the materialized views. So these are the main advantage of materialized views in Redshift. Now next is Redshift connector in Glue. Okay, so it is very easy. It allows you to read the data from Redshift and write data back into the Redshift. For example, I want to add first of all my e-commerce database is stored in Redshift cluster. Okay, so in that e-commerce database, I want to add some calculated field for average sales. Okay, so how can I do this? So we all know that we will use AWS Glue for writing the script using PySpark. Then it will use Glue connector, because Glue connector will be used to connect the Redshift cluster to AWS Glue. Okay, so it is the middle bridge between AWS Glue and Redshift cluster, and that too securely. Okay, then third step will be transformation will happen, extract, transform and load, this whole process will happen. And finally, Glue connector will use IAM roles to securely talk to Redshift cluster. Okay, so I will repeat one more time. What is Glue connector? It is the middle person between AWS Glue service and Redshift cluster. We can read the data from Redshift cluster and write back into Redshift cluster. Now let's check what is Redshift spectrum. Okay, so let's understand it with diagram. For example, let's say our data is stored in S3 and I want to query it from Redshift. So I cannot directly query it. I will have to first copy it in Redshift tables and then I can query that data, right? First, I will have to copy the data in Redshift tables. This was mandatory earlier, right? We cannot directly query. But now, using the Redshift spectrum, even if your data is stored in S3, you can directly query it from Redshift. Oh, okay. You can directly query the data in Redshift from S3. Earlier, you need to copy the tables in Redshift tables. Then you can query, but using Redshift Spectrum, you can directly query the data stored in S3 from AWS Redshift. So let's check what is the formal definition. It's a feature in Amazon Redshift that allows you to directly query the data stored in S3 without loading the data to Redshift tables. Okay, we do not need to load the tables in Redshift. We can directly query it from S3. I will just make some changes here. Not store, we can query. Allows you to directly query, not store. Yeah, this is fine now. So you understood Redshift Spectrum. Now next is cost optimization techniques in Redshift. So the name of these techniques are RA3 nodes and concurrency scaling. So first let's check RA3 nodes. So if you check the diagram, AWS is saying earlier Redshift was greedy, now he is not greedy. Let's check why he is saying like that. Okay. So earlier, before RA3 technique was found, in the Redshift cluster, if you want to increase the compute, you must also pay for storage. Okay, they were coupled. If you want compute, you must also pay for storage. But now, using the RA3 nodes technique, if you want more compute, you can take it. You do not need to increase the storage. They are now decoupled. Okay. If you just want to increase the compute, just pay for that. You don't need, it is not compulsory to increase the storage as well. Okay, so this is the advantage of RA3 nodes, and we can do some cost optimization using this RA3 nodes technique. Compute and storage are not dependent on each other. Now Redshift has some problem. Redshift is saying, bro, sometimes my workload spikes. So cluster gets overloaded with queries and speed is getting down. Because of overloaded queries, speed is slowing down. Now I want some solution on this, but I also don't have much budget. Okay, I don't have some money. Now current Redshift cluster you can check. We have one parent node and two child nodes. Now what is the solution on this? Solution is concurrency scaling. There is one feature where you will just temporarily spin new clusters. When your workload spikes, you are getting one temporary cluster. Okay, it is not, you are not permanently buying huge cluster, you are just temporarily spinning those cluster whenever workload is high. Okay, so you are saving cost because you are just paying for those temporary clusters. Whenever workload is high, you are just paying for those temporary clusters. So this way you are saving cost as well, and your speed will also not be down. Okay, speed will also be maintained. So this is the concurrency scaling. This is the second cost optimization techniques in Redshift. Now the last topic is AWS step functions. Okay, so let's observe the diagram. These four people, AWS Lambda, Glue, S3 and ECS, are recently working really hard in AWS. But these guys are fighting. they are not coordinating with each other. These guys are fighting for their order. Okay, so they definitely need one cloud project manager. Okay, so what is the solution? Solution is AWS step functions. Okay, so step functions is cloud project manager for all the AWS services. It can manage multiple tasks in the cloud. So step function will tell all these people when to start, when to wait, and when to stop the task. Okay, so he is completely managing this all the services. Step function will manage the multiple tasks in the cloud properly. And second thing is we do not need to manage the server. AWS will take care of the server for step functions, right? Step function is serverless.